11.8 power series. So finally we are getting somewhere where real life happens. So this topic is already of high interest to applied math people, and yeah, applied mathematicians do work with power series a lot. Okay, so the main objective for today's topic will be to find the radius and interval of convergence for power series. So let me remind you, what are our favorite functions, our pet functions? Definitely polynomials, right? We know everything about them, we can differentiate and integrate them anywhere, so life would be really easy if we had to deal only with polynomials, and pleasant, might I add. So imagine an infinitely long polynomial c0 plus c1 times x to the first plus and so on plus cn times x to the nth plus and so on. Okay, so that would be, we can write it as power series, as a series x to the nth, and we know that series will either converge or diverge, right? So if it converges, then it will be a different value for every x, right? So we can really say that we constructed a function of x. And if it diverges, it's gonna be infinite, so that would be not much of a function. So we would be interested only when it converges, right? Okay, so the general formula for power series is the following. We have different coefficient, and we also have x minus a to the nth, not just x to the nth. And this would be called power series centered on a, or we could also say about a. And about a comes from expansion, Taylor expansion, but we will talk about it later. Okay, so let's get comfortable with this formula. Imagine that a is equal to 0. Let's go as simple as possible, and all Cn are the same, and they are equal to C. Then this series Cn x minus a to the nth becomes c times x to the nth, right? Do you recognize it? 0 to infinity. So it's going to be c plus cx plus cx squared plus and so on. And this is geometric series, right? Geometric series. We know that geometric series will converge if absolute value of x is less than 1 and converges, and if absolute value of x greater or equal than 1, we would have it diverges. Okay, so this is a particular example of power series. And now you are ready to hear a theorem. If we have power series 0 to infinity Cn x minus a to the nth, it can behave in the following three manners. Either it will converge only for x is equal to a and converges and diverges for all other x that are not equal to a, right? then it can also converge for all x, converges for all x, and the case that you will deal the most with and the most realistic case would be when the series converges for absolute value of x minus a less than some positive value r, and diverges for x minus a is greater than this value of r, and in this case the value of r is called the radius of convergence. The radius of convergence. Note that the first case implies that the radius of convergence is 0, and the second case implies that the radius of convergence is infinity, right? Let me illustrate the very first case. So example 1 for case